as RAM. In this RAM area, you will write your program, right, which will be fetched by 8085, right, which will be fetched by 8085, and then your program will be executed by the processor. Along with this, 8085 will be interfaced with IO devices also. So IO ports has to be there, and right, this will be interfaced. Now if processor wants to write some data on RAM, right, it can do STA RAM location 4000H. So accumulator content will be stored here in 4000H, right? Suppose accumulator is say some 45H, so 45H will be stored over here. Similarly, if a processor wants to write something on some port, right, IO port, right, so here suppose this is IO port and port address is say 30H. We discussed how port address is of 8-bit only earlier by discussing a 4-byte RAM chip, right? And each RAM location will have the external pins like this, D0 to D7, right? So anyway, so 4 IO ports. Suppose a processor wants to write something on IO port, then it will do OUT 30H, 30 as the address of this port. So if A equal to FFH and this data has to be written over here, it will write out 30H, so FFH will be copied over here. So all pins will be 1 1 1 1 1 1 like this, right? And we discussed earlier how a single pin, any pin of port, can be used for controlling some switches, right? Like this. 12-volt relay coil is here, so it can turn on the contact, and contact may be given to power supply and it may be used to run a motor, right? So if processor wants to turn on this motor M, what processor is supposed to do? It will out 1 at this pin, right? So port address of this pin is 30H, and suppose this is D0 pin of port 30. So it will do what? It will out 40H on this, out FFH on this 30, port number 30, so that it will be all pins will be 1, or even if it outs 0 1, 0 1 means 4 zeros and 0001. So 1 000, then 4 zeros over here. So this bit will be 1, so this will turn on the motor, right? Similarly, if processor wants to read data from a RAM location, it will do LDA. So many instructions are there, right? LDA, say 5000H. Similarly, if processor wants to read data from some port, right, then it will write this instruction has to be there in port address. Suppose this port address is 31H, in 31H. So whatever data is supplied by this external device or IO device on this port can be read by the processor using this instruction in and port address where this external device is connected. Okay. Now, suppose your processor is busy in executing this program stored in RAM location. Right, it is a very lengthy program. Right, it's not going to end very quickly. And when it is executing the program, some necessary work has to be done, like turning on of the motor has to be done, or turning off a heater has to be done, or similarly a data is ready over here, then it has to read data from here. So how it will do? Right, processor will be interrupted via these external hardware interrupt pins, right? And we discussed last class, trap, right, is having highest priority, and it is a non-maskable interrupt, and its vectored location is 0024, right? H. We discussed all these, right? Then R RST 5.5 is the another hardware interrupt, right? This is level triggered. This triggering also we discussed. Trap is as followed by level, while RST 5.5 is level trigger only. RST 6.5 is level trigger. RST 7.5 will be S triggered, right? So now suppose processor is busy in executing your program which is stored in this RAM location, right? So now suppose this external device over here wants to send data, very important data, to the processor, right? So what it will do, it will, this external device will interrupt the processor using these interrupt pins, any of the interrupt pins, and based on the sensitivity of these interrupt pins, this device will generate. Now if RST 7.5 is being used for interrupt purpose, then this device should generate a spike or edge signal like this. And if it is using say 6.5 or 5.5, then it has to generate a level voltage like this. We discussed earlier how a level voltage will increase up to 5 volt and it will remain over here. Then these 6.5 and 5.5 will be recognized. But suppose, right, a voltage is increasing very, very slowly, and then it becomes 5 volt. And if this type of voltage is applied over here at RST 7.5, then it processor is not going to recognize this interrupt. So this sensitivity of different interrupt pins, their priority, their vectored location, all these things we discussed in last class. Now let us take the example how to use these interrupt pins, interrupt features for servicing the interrupting devices. All right, let us take the example. Okay, so problem 1, I am writing this. A motor has to be turned on by sending 5 volt to SOD pin of 8085. When an interrupting device sends .5 pin of 8085. Write a program to mask all interrupts except RST 5.5 and turn on the motor whenever whenever 8085 is interrupted via RST 5.5 pin by sending 5-volt pulse of high millisecond duration. So, new slide. Here we have 8085, right? It is interfaced with memory, mem, as well as IO devices, IO ports, right? And processor is busy in executing your program over here, which is written over here. It is busy in doing this. Now, moment this interrupting device one, this is RST 5.5 pin. Now another interrupting device may be connected over here. ID2 is also connected to say RST 6.5. Third interrupting device ID3 is connected to RST 7.5. Right, what is the problem statement? Right, processor is busy in executing your lengthy program over here. Right, whenever this RST 7.5 pin is having say this type of voltage, level voltage, which will be generated by this interrupting device 1, then 8085.
Excuse me, sir.
Yes.
Sir, please make everyone attendee, sir. Someone is removing.
Okay, very good. Thank you. Kare bhai, someone is 53 students are there. Someone is removing. Okay. I am not asking motor is, if say this type of pulse, right, it is of high millisecond duration, this is 5 volt, is sent to SOD pin, then of course here you will have some interfacing circuitry, and finally you will have here a motor which will have power supply, right? So if this motor has to run, or this right, suppose this interrupting device wants this motor has to run while processor is executing your program. So this interrupting device will send the interrupt request to this processor 8085 via this RST 7.5 pin. So if this RST 7.5 interrupt is not masked by the user, by you, then what will happen? This processor will stop executing your main program, right? Will stop executing your main program, right? And then it will branch to a subroutine where it will generate 5-volt pulse of 5 millisecond duration at SOD pin. Then it will return back to your main program and it will start executing that, right? Okay, so this will be the simple, very simple program we are discussing. So how to write the program for this? New slide. First of all, you need to know now the control words of interrupt, mask, right? So in fact, we discussed earlier how serial data is outed using SIM instruction, right? This is SOD, this is SOE or SDE pin of SIM control word, right? Now here it is, don't care, here it is R7.5, here we have MSE, then M7.5 is there, M6.5, then M5.5, right? M5.5. So this, sorry, Control Z. M5.5 is here, right? So out of these three interrupting device, ID1, ID2 and ID3, right, we have to use only RST 7.5. These two interrupts should not be recognized by the processor. This is what the problem statement, right? Mask all the interrupt except RST 5.5 and turn on the motor whenever 8085 is interrupted via RST 5.5 pin by sending 5-volt pulse of 5 millisecond duration at SOD pin, of 8085. Okay, so now till now we have discussed SOD and SOE pin bits function, like these two are ANDed and actually connected to SOD pin, right? So if you want to send 1, then you have to make this bit 1, this bit 1, so it will be 1. So output will be plus 5 volt. And if you want to make this one 0, then this has to be 1, this has to be 0, then it will be 0 like this, right? Now if this one is 0, right, this one is 1, then what will be output? Hello, forget about this. If this bit SOD pin is 1 and SOE pin is 0, what will be the output at SOD pin? SOD bit is 1, D7 bit of this control word is 1, SOE is 0. What will be output at SOD pin of 80? Okay, yes. So if you want to send something at the SOD pin, then you have to make this bit 1, right? Okay, now suppose we do not want RST 7.5, this interrupt, and RST 6.5, this interrupt should not be recognized by the 8085. Then we are supposed to make this one 1 and this one 1, right? And we want our RST 5.5 interrupt has to be recognized by the processor. So this bit we have to make 0, right? So this one is the mask set. This one is the mask set for 3 interrupts, RST 7.5, 6.5 and 5.5, right? This mask set, this 1 or this 0 or this one will be valid, will be activated only if mask set enable is 1. So if you put this one 0, then these three 1, 1, 0 are meaningless, right? If MSC is 0, then 1, 1, 0 is meaningless. It doesn't mean anything. But if this one is 1, right? This is 1, this is 1, this is 0. It means 7.5, RST 7.5 and 6.5. Even though these devices are sending these type of signals to 8085, 8085 is not going to respond to these two interrupts. Okay, so mask set has to be 1, right? We have extra control of RST 7.5. If you make this one 0, then RST 7.5 is enabled. If you make this one 1, then RST 7.5 is disabled with extra bit. Okay, so let us make this one 0 first, because we do not want to send anything at the output side, right? At SOD pin, if you do not want to send anything, then this has to be 0, right? This either you put 1 or 0, there won't be any effect at SOD pin because SOE pin is 0. So it will be high impedance state. So let us make this one 1. You can make it 0 also. This is, don't care whether you put 1 or 0, it's not going to have any effect. So let us put this one also 0. R7.5, even though if you put this one 0, here mask is there. M7.5 is 1, so 7.5 won't be recognized, right? So even though if you put here 0, if you put here 0 and if you put here 1, then also RST 7.5 is not going to be recognized. So extra control is available over here. So let us make this one 0, but mask is already there and this has to be 0. So what will be our control word? It will be 8 and this will be E, right? So very first instruction has to be this MVI A 8EH. Now moment you write SIM, what will happen? Right, moment you write SIM, accumulator content will be pasted over here in SIM control register, right? So at SOE bit will be 0, right? SOD pin will be 1, but since this is 0, so at SOD pin it will be, nothing will be outed, right? It will be high impedance state. This is 0, so no role. MSC is 1, so these two are masked, right? Now next you have to do this EI. This instruction is also one of 1 byte and it is used for enabling interrupt. So it is enabled. Next, you can write any LXI SP stack, right? Because stack has to be initialized, right? Then suppose this is MVI A01 ADI 01. This way, suppose your program is there, right? And it is executing, say, this instruction, add C. Then we have add B. Then we have add L. And it is continued. And finally, here we have HLT, right? So you have given this. Now, in order to execute your program, you have to give a starting address. So PC will be loaded with your starting address. First of all, it will execute this. Then it will execute this. then it will execute this. So interrupt mask is set, only RST 7.5 will be recognized. If 3 devices are interrupting the processor, then only RST 7.5 will be RST 5.5 will be recognized, because we have set the interrupt mask according to that, right? Then it will continue with this MVIA 01, 01, 01. Suppose processor is executing this, so program counter is here, right? Program counter is here. It has fetched the opcode of addc and it is adding that, right? So suppose processor is fetching addc command and it is executing that. So what will be program counter? Hello? Anyone? Abhishek Agarwal?
Yes, sir.
If processor is fetching addc command, right? Addc opcode is fetched and it is executing addc. What will be the program counter? Hello? अभिषेक अग्रवाल?
Yes, sir. Yes, sir.
हाँ, प्रोग्राम काउंटर क्या चीज है भाई, जरा बताइए तो आप। प्रोग्राम काउंटर का रोल क्या है?
सर हम थोड़ा सर क्लास तक नहीं कर पाए थे, हमने अभी स्टार्ट करी क्लास करना, इस वजह से सर।
तुम तो हर रोज प्रेजेंट रह रहे हो मीटिंग में भाई।
सर मीटिंग में आते थे सर, लेकिन
anyone can tell that if processor is executing addc command, what will be the program counter?
Sir, in which command, sir, you are talking about?
addc I am saying, no? How many times I will say? It is executing addc command. Is it clear? What do you mean by processor is executing addc command? You know?
Yes, sir.
It is fetching the opcode of addc from memory and bringing that one to instruction register. It is decoded. Then accordingly C register will be transferred to temporary. Then A plus C will be added and result will be stored back in the accumulator. This is the process. Is it okay? Am I
Yes,
correct?
sir.
Yes, sir.
So what will the program counter? If processor
Sir,
is
address of next instruction, sir.
address of
Next instruction.
हाँ तो next instruction क्या है?
Add B, sir.
हाँ so it will have the address of add B. So
Yes,
PC will be over here, right?
Yes,
PC
sir.
will be over here, but processor is executing addc command,
Yes, sir.
right? At that point, suppose क्यों नहीं जा रहा है इसमें जी? At that point, suppose this interrupting device sends this type of signal at RST 5.5 pin. What will happen? Right? What will happen? Address of this add B, which is the address of the next instruction, will be pushed onto the stack. Right? So suppose stack pointer is here. Right? So stack pointer will be decremented by 1, SP minus 1. Right? And higher order address of add B. Suppose this address I am writing. 5075 is the address of this add B command. Okay? So what will happen? Processor will push this address 5075, which is address of add B, onto the stack. So 50 will be over here and 75 will be over here, right? And program counter will be loaded with what? बताइए, प्रोग्राम काउंटर किससे लोड होगा जी? Will be loaded with vectored location of RST, बोलिए, 5.5. And what is that address? RST 5.5 vector location is 002C. 002C will be loaded. Now, processor will start executing your command from here, 002C. So in last class we discussed, no? Where is interrupt structure? कहाँ गया जी? ये देखिए 002C है कि नहीं? यहाँ this is ROM location, no? Hello, this is ROM location. Why it is not writing? This is, oh, here, draw. This is ROM location, right? So it will branch to ISR of RST 6.5. So here at 002C, you will find what? C3 will be jump instruction, then 0040 if it is written over here. In last class we discussed, since this is a ROM location, this vectored location is ROM1. C3 0040 is written. This is ROM area. So here you cannot write your ISR. ISR you cannot write over here. So now 002 from here 5075 will be pushed onto the stack, right? And stack pointer will be pointing over here. Program counter will be loaded with vectored location of RST 5.5. So it is 002CH. And at this location, JMP, C3 stands for JMP. 0040 means 4000H. So from here, processor will branch to which location? 4000H. Now your PC will be over here. Program counter will be over here. Now this is RAM location provided by the kit manufacturer, right? Provided by the kit manufacturer. So here you can write your ISR. So let us write the ISR now. New slide. ISR of RST 5.5. Right. So it is starting from which location? 4000H. Now suppose in this case what we are supposed to do, whenever it is interrupted, Now 8085 has to stop this execution of main program. So it was executing was add C, no? Add C. So add C is completed, and next instruction address, add B instruction address is pushed onto the stack. Then it branches to 4000H, which is over here, 4000H. And there it will execute the ISR. So in ISR, you have to send what? MVI A C 0H. SIM. What exactly it is going to do? 1100. So this is what? M7.5, M6.5, M5.5. This is MSC. Right. So all these are not effective, no? Since MSC is 0, so whether you are putting 0 or 1 here, it's not going to change your interrupt mask. Right. Here R7.5 is enabled, but so make it 1 anyway, right? So these are not meaningless. So only this one is meaning. This is SDE or SOE. SOE. So what will happen? This will go to SOD pin, no? Now you have to do what? Call delay of MVIA 40H. So 4 means 0, 1, like this, 40H. So now SDE is 1, SOE or SDE, SOE or SDE is 1, while so this 0 will go to SOD pin. So you are going to generate a pulse like this of 5 volt. This is of 5 millisecond. Then after 5 millisecond, it is becoming 0 volt, no? So this will do what? It will turn on your motor. Of course, SIM has to be there. Now, motor has turned on. Now processor has to return to its main program. So now this instruction has to be written. So program counter will be over here, 4000H. Then it will come to this instruction. Then it will come to this instruction. From here it will branch to delay subroutine. Delay subroutine. Here you will find RET. So again it will come back over here. Next instruction address. Then it will do this. Then from when this return is encountered, what will happen? It will fetch the program counter from this stack. Right. Another important point over here, when we are calling this delay subroutine of 5 millisecond, MVI A address, suppose it is 4055. So what will happen? यहाँ पे 4055 will be pushed. And stack pointer will be over here, right? So when this delay subroutine is called, right, address of this next instruction MVIA 40H, which is 4055, will be pushed onto the stack. Program counter will be over here. Now it will execute this, and moment this return instruction is encountered, what will happen? It will pop the address from this top of the stack. So 4055 will be the program counter, and it will come to this. Okay, then it will come over here. Here program counter will be over here. Finally, it will execute the return instruction. So when this return instruction of this one ISR is executed, it will fetch, or program counter will be retrieved from top of the stack 5075. So 5075, now program counter will come over here. Now it will do add B operation, then it will do add L operation, right? And finally it will finish this main program. Hello?
Yes, sir.
If you are not following, then you can ask, because it's a means. So should I go for another example?
Yes, sir.
RST 6.5. RST 7.5. This is 5.5. ROM, RAM, IO device, IO ports. Right. Suppose in a hall, if a person enters, then RST 5.5 interrupt is generated. If a person exits or comes out from the hall, then RST 6.5 interrupt is generated, rated. This is 8085. Web to count number of persons inside the hall and display glow a red LED connected at SOD pin if count is greater than 99. Hello? COUNT count is greater than 99. Hello? Is this problem statement is clear?
Yes, sir.
Right. If a person is entering into a hall, then RST 5 point sensors are placed. So definitely door is going to open, no? When person is entering, he is going to pull the door. So RST 5.5 interrupt will be generated. If person is coming out from the hall, then it will push the door. So it is pushing, so in other direction it is pushing, so it will generate, say, RST 6.5 interrupt. हाँ Raghavendra. The person is coming out, then of course it will push the door, then other type of interrupt will be generated. So processor is going to recognize these two interrupts, right? And based on the interrupt, it will increment or decrement the count, right? Now, if count is more than 99, then make it 98. Otherwise, it will be more complicated. 99, there won't be any problem. If you count in the hex, no, there won't be any problem. Okay, 99. Right. So then we have to glow a red LED connected to SOD pin. So what will happen? LEDs.
Sir, we have a quiz right now, sir, for open elective, sir.
अच्छा, तो आप ज्वाइन क्यों किए क्लास को? फिर मतलब 10 बजे तक हमको रहना है या 9:50 तक ही रहना है? बताइए आप। 9:50 ही है ना शेड्यूल टाइम, शायद हम 7 मिनट ज्यादा ले लिए। अरे ये तो गलती हो गया हमसे जी, सॉरी। I am saving this. We will continue with this program in next class. Not a problem. Right. Okay. So now all the best for your quiz. I am closing this meeting now.